So, hello everybody. My name is Ashley Kowalski, and I was a crew member for SIRIUS-21, specifically the flight engineer. And SIRIUS-21 was an 8-month astronaut analog mission held in Moscow, Russia. And we were living and working in there with a crew of 5, multinational crew. We had participants from Russia, the US, and the United Arab Emirates. So let me move on here to the next slide. So SIRIUS stands for Scientific International Research in a Unique Terrestrial Station. It is a joint effort between Russia's Institute of Biomedical Problems, INBP, located in the heart of Moscow, and NASA Johnson Space Flight Center's Human Research Program down in Houston. The purpose of the study, of course, is to better understand the effects of isolation and confinement on the human body, whether that is psychological effects, physiological, immunological, emotional, mental, you name it, we're trying to study it. And so the SIRIUS missions are, the one that I did, SIRIUS-21, was a series of several missions that were already completed. So in 2017, there was a 17-day mission. In 2019, there was a 4-month mission. One of the participants of that is actually over there in the audience, Anastasia. And then, of course, last year we did the 8-month study, which we just completed in July 3rd, 2022. Beyond this, there will be a 12-month study, and with the potential of multiple follow-on year-long studies after that. We conducted during our mission about 70 different experiments, and those experiments were submitted to us from countries all over the world. We had experiments we were running, of course, from Russia and US and the Emirates, as we had participants from there, but also Germany, France, Italy, Canada, the Czech Republic, Japan, and other countries as well. So really a multinational, international effort. So just a quick meet the crew. So as you can see, I am wearing the official SIRIUS-21 flight suit that we had during our 8 months. Oleg Blinov is a former cosmonaut select. He was our crew commander. I was the flight engineer. Victoria Kirichenko, she was our crew surgeon. And then we had 2 mission specialists, William Brown from the US and Saleh Al-Amri from the United Arab Emirates. And down here in this photo down here, I didn't want to shortchange our backup crews. So prior to the mission start, we had 2 months of training in Moscow, and each one of the prime crew members had a backup member as well. And so they played a large part in our preparation. And of course, they were ready to step in at any moment. And a good example of that is that our Emirati crewmate, Saleh, was actually the backup crew member initially. And at the last minute, we had a switching crew member. So he was ready 2 days before the mission started. He jumped in and really impressed us. So the facility that we were in, it's the NEK Facility, NEK, because that stands for, in Russian, Наземный экспериментальный комплекс. So it's a ground-based space simulation. And the facility is a completely hermetically sealed facility where they can control the temperature, the humidity, the pressure, the CO2 parameters. It has its own water supply system, sewage system, and all of that is controlled by the engineers and mission control on the outside. But on the inside, we can also monitor those factors. So if we saw something that looked abnormal, we would be able to contact mission control and help understand what we can do to fix the situation or alert them to the issue. So you might also, so this is actually quite a historic facility. Again, it's in the heart of Moscow at the Institute of Biomedical Problems. Many of you, I'm sure, are familiar with the Mars 500 study. The Mars 500 study was where a crew of 6 stayed in this exact same facility for 520 days. So let's move on here. All right, so I apologize for the super speed of this. If I had extra time, oops, let me turn let's see if I can turn is there a way I can turn the volume off of that? I thought I had it off, but well, maybe not. But well, sorry, I'll take a pause really fast. Is there a way I can do that? Because I really would like to show you guys at least a sped up version of the tour of the facility. If I had more time, I would just play the entire 15-minute segment, but I sped it up 4 times. So disregard the fact that it looks a little bit silly with the high speed, but I think it really gives you a good idea for the layout of what we were living in for 8 months. And oh no,
Sorry.
no, that's okay. Let's see, can I get out of the presentation view and mute it?
There you
Oh, all right. Well, no, that's okay. We'll skip through that then. We did a lot of different psychological studies. That was the main component of the experiments that we were doing. And so, we had a lot of surveys, a lot of questionnaires that we were doing throughout the time to evaluate our crew dynamics, our emotional and mental health, our just general well-being. And a lot of times those surveys were paired with blood samples and saliva samples that were taken in order to compare our answers to our cortisol levels, things like that. So there were so many surveys. They were pretty much the bane of my existence in isolation, but they were helpful to our researchers, of course. We had perception of time studies. We did weekly EEGs on ourselves. That every other week were paired with different cognitive tests. So over here in the picture over here, I have myself, it's a picture of me preparing an EEG on myself. So we had electrodes on our body. And then once the signal was verified on the EEG, the system measured our our brain activity state when we have our eyes open versus closed. And then afterwards we would do a cognitive test.
I think I can.
Oh, sure.
If you want to go back.
Yeah, sure. We would do a cognitive test that basically on the bottom of the presentation, we have, nope.
I tried.
Okay. All right. So the door behind me is where we entered the facility. And I'm standing right now in module 250. So module 250 was the module where we had all of our storage, all of our equipment, all of our food, all of our hygiene needs and sanitary needs. And over here, I'm showing you some of our food tube samples. So this was basically how a lot of our food looked like. We had sublimated food here, which is basically dried food that you would add water into and make it into a food. We also had some ready to eat foods in there. Over there, we had some pickled beets, a Russian specialty, some canned goulash. Everything was coded together by number and shelf location. So we knew what was exactly on that shelf. We could use a scan code to know what we have there. Over here, I'm showing you the NASA glove box, which is what we would use to analyze the lunar samples from our simulated lunar missions. That computer is where we would look up any inventory that we wanted to make sure we had enough food left for the rest of the mission, for example. 3D printer that I just showed you. We're entering the workout room. That's a NASA weight training machine. Over here is our greenhouse where we grew enough that we could make a nice fresh salad shared among 5 of us about once every 2 weeks. Over here is our active treadmill and passive treadmill. This is our shower area. We were able to take a shower once a week. That was one of our bathrooms. This hallway is where it connects module 250 to 150. But what I'm showing you right now is the lock that basically we sent out any of our blood samples or urine samples or saliva samples, in addition to our trash or dirty clothes. And we did that to maintain isolation and not see the outside world. Currently, I'm in a kitchen, which is in module 100. We decorated it pretty nicely, but this is where we would gather 3 times a day to eat food. I'm showing you our weekly schedule here. Everything was scheduled for us to the 10-minute mark pretty much. So we knew what we were doing when, what experiments we were running when. Down this hallway is our rooms, our individual rooms. We could decorate them as we want. I'm showing you how big they are. Basically, width-wise, it was about this big. But there was complete privacy in there, no cameras. This is our daily planning conference room. That is, as the flight engineer, that is where I was making sure to check all of our module parameters. That lock is what connected us to our lunar module, module 50. It was only opened up when we were doing extravehicular activities. That's another bathroom for us. Walking back down this hallway, we'll hit our leisure room. So we did have opportunities to relax, watch a movie. We could also do work in there. And then as I crawl through this lock over here, we enter into module 100, another bathroom. And this is where the majority of our experiments were. That's a bone density experiment. That's a rover simulation. That's a docking simulation, virtual reality docking simulator. Continuing on, lunar rover simulator. We've got our EEG device there, another EEG device and FNIRS cap, an eye medical device. We have the cardiac machine right there. And it looks like we're glitching, but that is basically it at that point. I'm not sure why that happened, but that's okay because it was basically done. And the only other thing at the end of this that I wanted to show you is that we were under constant video surveillance at all times, no audio, so they couldn't hear what we were talking about, but they could always see what we were doing. So there was nowhere to really hide except for your own individual bedrooms. And of course, the bathrooms did not also have clearly cameras in them. So I mentioned daily planning conferences. So I wanted to point out on this side, the two on your left. So every morning and evening, we would talk with mission control about how we're doing. Did we have any problems? Do we have any questions? And just checking in with them. And while that was part of our operational task, it was also a psychological study. Because we had a high fidelity audio device in front of us. And also, of course, they were recording all of our video messages. So they had software that could analyze our voice and our facial expressions to see, to kind of analyze our emotional and mental and psychological health. The next one on the other side, the fourth photos over there, that was a study of the mitigation of mental stress. So if you'll notice on the computer screen, it says yellow, but it's shown in blue. And on the bottom, you have different colored blocks, and there is a name of a color in them. So the researcher, in order to create a stressful situation for us, he created this program where, if we saw yellow in blue, we would see the word yellow. And of course, we'd maybe be confused because we're seeing it in blue, but that means that we need to choose blue because it's the actual color, not what's written there. It's a lot of words, but basically during that experiment, we would take a saliva sample in the beginning, then do an EEG, and then do 10 minutes of that stressful assignment, take another saliva sample, change into an FNIRS cap, and then after that, do 10 minutes again of that stressful scenario, and then another saliva sample so that the researcher can analyze, again, your cortisol levels and your stress rates during those times. Let's see. Next. So for teleoperations, this was a study submitted by French researchers. And basically this was to study and evaluate the impact of isolation and confinement on an operator's teleoperation performance. And we did this by running a software program and performing a software program where we were building a lunar base and collecting lunar samples. So we would put electrodes on us so that they could track our cardiac measures. And we also had a visual tracker in front of us to see our ocular motor activity as well. And so I created a little video here. So this is once I put the electrodes on my body, those were peaks showing my cardiac activity. This is what the simulation looked like. This is a video of the eye tracker. That's me. And then you can see we are also picking up lunar samples. And we did this, I believe it was once a week or once every 2 weeks. And the researchers are trying to understand, did our performance stay the same? Did it improve? Did it degrade over the 8 months of isolation? And this specific study is also going to be done with actual astronauts and cosmonauts on the ISS. And next here, oops. We also use virtual reality for sensory stimulation. So this study was done to assess the feasibility of a very immersive virtual reality environment and see if that gave us a positive effect and helped our mental well-being during our isolation and confinement. And so this is what we saw in those virtual reality glasses. So you usually started with a nice fire pit. It takes you into something that looks like almost Sequoia National Park. You have prompts in your ear asking you, how are you feeling? Like all this stuff. Well, what's changed since last time? And you can talk out loud. You have your private moment. Then you go into space. You have a fully immersive experience. And then you have a survey at the end that says, well, how do you feel in this moment? And in addition to these types of factors, there was also blood samples and saliva samples, again, collected throughout this particular study. So also to check our cortisol levels. And next here, we also use virtual reality for docking simulations. And so in this particular study, the researchers are hoping to understand how our piloting skills degraded, or again, maybe stayed the same, maybe improved, basically the quality of our piloting skills during a long-term isolation and confinement mission. And so this was a German study submitted to us. This was the panel that we saw, and I will go to the next slide because I did another video here. Let's see. So this is me on the virtual reality. Looks like I did not. We'll just let Will talk. So let me just go back a slide really fast here because so every month we had to do one of these docking simulations, and during that session we had 3 specific dockings to do. One was using only visual parameters. The second time was using only instrumental parameters, and the third was a slightly more complicated situation where you use a combination of visual and instrumental. And so it was checking also our hand movements, our eye movements, again, in order to understand piloting skills and whether or not they degraded. So let's move on next. Okay, so at this point, I'm moving on to some of the physiological studies. I'll do a time check here. Okay. All right. So for physiological studies, so gastroenterography, this was a multi-component study where sometimes we wore electrodes for 24 hours in order to understand the electrical activity of our gastrointestinal tract. We had ultrasound for our organs. We did Urey's breath tests to understand the bacteria in our stomachs, bicarbonate breath tests, carbohydrate breath tests. That was for our glucose metabolism and function of our pancreas. Is a multi-pronged thing. And so some of the tools that we had up there were what we used for our sampling. We had respiratory studies as well, assessing the state of our respiratory parameters and of our respiratory muscles, the strength of our muscles. Did they degrade in isolation? Next, we had some studies that analyzed the whole body energy consumption and energy content. We used laser Doppler flowmetry to assess the changes in our microcirculatory bed. So basically, it was a small laser that once it touches the skin, so basically we did it on our foreheads and on our non-dominant hand. And basically once that laser hits your skin, the light undergoes a change in wavelength. It's like the Doppler, it's a Doppler shift essentially when it hits those moving blood cells. And so the LDF, the laser Doppler flowmetry, it analyzes the velocity of the blood cells in order to see the changes in your microvascular system. All right. So acid-base balance. So for this one, this was essentially an assessment of the gas composition of the blood and the acid-base state at rest and during a physical activity. So that involved usually taking a drop or more than a drop of blood, a small little sample of blood from your finger. So we did that at rest, usually right when we woke up before we had any food, and then also during a physical activity. So over here, we're on a bike. Once you're, I think we went up to like the 85% of our max rate. And then another crew member, in this case, Oleg Blinov, our crew commander, would come over, take a sample of our blood, and then see see how the gas composition of our blood changed, our capillary blood. Next here. All right, so over here we have PRBS, pseudo-random binary sequence and cognition tests. So this was a test that combined physical test with cognition. And so basically, while we're running, we had a VO2 mask on us. Before and after isolation, we also did FNIRS on our caps. And then we also had a flanker test in front of us. So as I'm running, I can turn this on here. As I'm running, you'll notice I have two clickers in my right and left hand. And so based on what that center arrow, which way that center arrow is facing, I need to click right or left. So this is particularly important for, let's say, something like an extravehicular activity, where you are doing strenuous physical activity for multiple hours, but you need to maintain your cognitive abilities. So researchers are trying to duplicate that kind of an environment in a laboratory setting and as closely as possible, and also see how how isolation and confinement affected us throughout those 8 months. And next, oops. We also had sleep deprivation studies where we had sleep fragmentation, sleep restriction, and full sleep deprivation. Fragmentation meant that we had to wake up every hour of the night for the entire night and then perform some tasks. We also had restricted sleep, about like 5 hours of sleep, and then have to get up and do some tasks, and then full 38 hours of sleep deprivation to see the effects on our autonomic nervous system, and then also how we recovered afterwards. So we would sleep in these really attractive devices on us. And also, let me go back really fast. During that time, we also collected blood samples, saliva samples. We did echocardiography measurements. We did blood pressure measurements. And the reason they're doing that is because they're trying to map out biomarkers that could say if a person is more reliable in those types of sleep deprivation environments, or if they're more vulnerable to not performing well. And hopefully they'll use these types of biomarkers to select crews that'll be more ready for those kind of situations for future long duration human spaceflight missions. And I'm really running out of time, so I'm going to speed through here. We did a couple of extravehicular activities, 3 in total, that included virtual reality tasks, body unloading system, and a lunar rover when your arms are also unloaded, so it feels like you're on a lunar surface. So I think the best way to talk about this, here's a couple of pictures of our crew, but I will skip over to the video as that's more exciting. So this is the mission control room as they are watching over our EVA. The virtual reality environment is what we see through our virtual reality goggles. Over there, I am in the body unloading system that is simulating the lunar environment. These are the 2 crew members during that particular EVA that stayed behind in the orbital module, while the rest of the 3 of us went out into the lunar module. Here's Victoria and I are donning our virtual reality goggles in our lunar lunar suits. This is our view, first person view. And this is Will. He's back in the lunar module doing communications with us, telling us, what we need to do, when, letting us know how to fix any problems we encounter. This is a close-up of me on the body unloading system. So again, we're lifted up so that it feels like you're on the lunar surface, but we also have a frictionless, or a reduced friction surface. This is me on the arms unloading system where we're doing the lunar rover activities as well. And then fun last couple of slides. So we have, different examples of food. Of course, I showed you in the video tour that we had sublimated food in packets and tube food. The tube food was kind of like we would have Texas burger or Sicilian pizza or chicken and mashed potatoes coming out of a tube. And it's basically this puree paste type of consistency. Think like pate or something like that coming out. Some sublimated soups. So it honestly, like, I mean, looking back at it, it looks pretty good, right? So we ate well. Over here, we have a fresh salad on the bottom center that is from our greenhouse. And then next slide here. Oops. Speaking of our greenhouse, we did manage to grow some tomatoes. We had green onions, different wheats, different lettuce. And then we also had to do physical activity. So for running, we ran 3 days on, 1 day off, 3 days on, 1 day off, usually in a stochastic type of run where you go from high speeds to low speeds, high speeds to low speeds. We also had 2 different weight training machines. We had the NASA weight training machine in the center. The Russian developed weight training machine is over here on the left. And of course, like when we're training, we're not wearing the masks like we do during the tests, but I wanted to show you that that is what our passive treadmill looked like. So we had 2 options. So the passive treadmill, of course, is one where you're motoring it only with your legs. We did have a couple of operational tasks, lunar sample assessment in the glove box, computer and device maintenance and repair, lunar landing site identification, acoustic monitoring, light monitoring, 3D printing, and then space robotics, which was a fun one. That is a Russian study. And I do apologize for the volume again. I thought I turned those off, but basically this device is a very human-like exoskeleton that really mimics all the movements of the human body down to the individual finger movements. And it's used for distance operations. So for example, if you're on Earth or on the ISS and you want to do lunar samples, pick up lunar samples or do a small construction, that is what we would use. And we're testing right here the use of virtual reality as a training device for that. Got it. Almost done here. Crew samples. Crew samples. Like I said, throughout the presentation, we were giving pretty much every type of sample you could imagine: blood samples, urine samples, hair samples, poop samples, saliva samples, you name it, we probably gave it to researchers. So that was really fun. And then just the final slide for us. I'm really proud of us. We did it. We managed it. And one last slide. I will be doing another analog coming up at the end of November. I am an employee of the Aerospace Corporation. So this is a company-sponsored mission. So we're crew number 269. So I just wanted to give a quick shout out for our crew. And with that, I don't know if I have time for questions, but maybe 1 question or 2 questions. Or, oh, sorry.
Hi, congratulations. Awesome. That's pretty interesting. So from your subjective perspective, were there any cognitive senses or capabilities that you think were affected the most during that time?
You know, it's from my subjective point of view, I actually felt that my abilities were almost improving during that time. Like my docking skills for the VR docking simulation, I felt like I was only getting better and better throughout the simulation. Because, you know, I knew what I did wrong last time and I knew what the situation would be next time. So I knew what I wanted to improve. And so I felt like I was constantly improving actually, but we'll see what the researchers actually say with the final analysis. They have a couple of years to analyze the data. Yeah. Yeah, we were completely isolated. That's very possible. I mean, we were not, you know, we did have access to, you know, news coming to us and stuff, but it wasn't a typical, you know, social life or work life or things that were distracting you. It's, yeah, I think that definitely helped. I don't know if there's, yeah.
Hey,
fill out so many questionnaires. If you're on the other side, how would you design them to be more effective?
I feel like the questions were very, very generic. I think researchers could actually get more out of surveys that gave us more ability to, write comments in there. For example, some of the surveys asked us, how did you feel in this certain module doing this type of experiment? And I could say like, oh, it made me feel happy, or it made me feel like, whatever the options were. But what was hard for me to understand is they don't understand why I feel happy in that situation. And so I really wish that I had more opportunity to write my personal comments. And I think that would help researchers, honestly, because some days the module might make me feel upset because, it's giving me flashbacks to an experiment that I don't like doing. Or maybe one day I'm like, oh, I did really good on that. Like I'm rocking this now. Like I like being in there.
Right. Stelly Ford, Moondown. So you said you're with the Aerospace Corporation. What was the name of the company?
Yeah, the Aerospace Corporation.
Yeah. So that's very interesting to me. So did they sponsor your trip to Sirius? Or are they just doing the Mars Society?
No, so
sponsoring?
I took a complete leave of absence from Aerospace to do this because this was a NASA sponsored project. So I was technically under NASA Johnson Space Flight Center for this year. But now I'm back at Aerospace, and the Mars Desert Research Station mission that we're doing is completely sponsored by our Aerospace Corporation.
So what is the value to them for you going to MDRS, and were they in any way involved with supporting you towards Sirius in terms of that leave of absence?
I mean, I would say the support for Sirius was more, they know that this is something that'll help me with career goals and things like that. And so that was really the support there, but they didn't have any studies or anything that we were doing for Sirius. However, for MDRS, so for long duration space missions, for the 8-month one, for example, that's more about psychological health, honestly, more than anything. And the 2-week MDRS missions, you can't really see changes like that in just 2 weeks. So our goal for Aerospace is really to test out more the operational nature of some equipment that we're developing, to see, okay, like, is this, from a human factors perspective, like, does this equipment, work on an actual EVA, or did the plan for the mission work out in such and such way? So it's more it's looking more at the operational aspect of things rather than the psychological and physical change aspect.
Very interesting. Thanks.
Thank you, Ashley.
Thank you.